Hi again, intermediate algebra students. You're stuck with me this unit for the videos. This is chapter 10, and our first one is lesson 10.1, factors and greatest common factors. Now, as we talk about factors, factors are things that are multiplied together. Oftentimes they're numbers. For instance, in this case, 6 times 7 is 42. 6 and 7, of course, are the factors. But eventually in this chapter we'll really focus on expressions. For instance, you probably remember that last chapter we were doing things like this. We were multiplying these binomials to get a product like this. So in this case, x plus 2 and x minus 4, those are considered factors. Now, some of this stuff, by the way, here's the show fear factor, which some of you may enjoy, but factoring is nothing to fear, hopefully, and we'll show that to you in this unit. Now, here's some basic vocab stuff that you might have heard before. By the way, I'm assisted by my cat Puma, who is sitting next to me here at my home. So if you hear anything weird going on, it's her. All right, prime numbers are whole numbers greater than 1 whose only factors are 1 in itself. And we could list some prime numbers. The smallest prime number, of course, is not 1 because it has to be greater than 1. So 2 is a prime number, and 3, and 5, and 7, not 9, but 11, 13. That's just a partial listing of some of the first prime numbers. And a key thing that we'll work on in this chapter, in this particular lesson anyway, is something called prime factorization. And that means we can write any number as the product of prime numbers. That's called prime factorization. So we have two kinds of numbers. We have prime numbers, and then the other ones that are not prime are composite. Those are ones that have other factors other than 1 in itself. All right, just some examples here of how this works. Let's see if we could find the factors of 84. And we'll just kind of list them. Certainly 1 times 84 is 84. And 2 times 42. Actually, 84 can be divided by 3. And it's going to be 3 times what? Let's see, I'm drawing a blank here. 20. I just got to check my answers here a second here, Puma. 3 and what? I'm drawing a blank here. So 3 and something. 4 and 21, and not 5. How about 6? Yeah, 84 can actually be divided by 6. So it's going to be 14 times 6. So I have all kinds of factors here for these, for 84. Okay. So anyway, now let's get back to the swing of things here, prime factorizations. A couple different ways to do that. The factor tree is something that you might be familiar with here. And that's where we just start with a number and we just start multiplying it by prime numbers. So we can write 84 as 2 times 42. Now I can't break 2 down anymore because that's prime. 42, I can break that down into 2 times 21. 21, I can break that down into 3 times 7, and then that's pretty much it. So if I look at what's left at the bottom of these factors, then that shows me what the prime factorization is. So I can actually write 84 as 2 squared, maybe, times 3 times 7. So you might have been accustomed to doing that to find prime factorization before. Now let me show you another method which maybe you know about, maybe not, called the factor stairs, or sometimes I like to call this upside down division. Same type of thing in some ways, but in this case we're just dividing by prime numbers all the time. So 84 divided by 2 is 42. I can divide 42 by 2 to get 21. 21 I have to divide by 3, and so I get 7, and now I'm done. And so now all I have to do is look at the stairs, so to speak, or these numbers on the outside for my prime factorization. And sure enough, I get the same thing, 2 squared times 3 times 7. So we'll have you do some stuff like that called prime factorization of actual numbers. You might recall doing that before. Now, here's something that's a little trickier though. Can you actually find prime factorization or factorization of expressions like this? Remember from last chapter, this is called a monomial. Well, it's got a number part, then it's got some variables. Now, we'd like to be able to factor 50 first of all, so I'm just going to do my factor stairs here. I know that 50 can be divided by 2 to get 25, and I divide 25 by 5 to get 5. So certainly the answer for the 50 part there would be 2 times 5 squared. Now when we have the variables like that though, all I do is really just sort of split those out. A squared I would write like that, and b to the third I would write like this. So that's how I would factor that particular monomial. Now here we have something called the greatest common factor, and that's the greatest number, and by number I have that in quotes because it won't always be just numbers. Sometimes it'll be algebraic expressions with variables and powers and stuff like that. So I'm going to try to find the greatest number that's a factor of all the integers or variables. And again, you might remember doing this before, perhaps. A couple ways you could do this. Here's an example, finding the greatest common factor of 60 and 75. Well, first of all, I am going to do my factor stairs here for each of these numbers. So I can divide 60 by 2, I can divide 30 by 2, I can divide 15 by 3, like that. Do the same thing with 75. 75 I have to divide that by 5, and then 15, and I get it like this. So I'm going to write the prime factorization. 60 is actually going to be 2 squared times 3 times 5. 75 is going to be 3 times 5 squared. So what I'm going to do then to find my greatest common factor is I am going to, first of all, pick a nice color here. I'm going to look at each of these factors, and it has to be what they have in common. So notice what they have in common here. They don't have any 2's in common, but they do have a 3 in common, like that. And they do have 1 5 in common, not 5 squared, but 1 5. So the greatest common factor has to be just 3 times 5, which would be 15. Okay, that's one way to approach that. Another way you can do it is like this. Careful, Puma. Is I have 60 and 75 like this. I'm just going to start doing the factor stairs, but I'm going to do them with both numbers at once. So can I think of any number that goes into both 60 and 75? Well, yeah, 5 does. So 60 divided by 5 is 12. Uh-oh. For some reason I can't write here. Okay, I'm back here. Had a slight cat malfunction there, I think. So 60 divided by 5 is 12. 75 divided by 5 is 15. Is there any number that goes into both those? Yeah, it's going to be 3. And then I'm done, because when I end up with here, I can't divide anything the same anyway into both 4 and 5. So once again, there's my greatest common factor. That's another way of. Last slide here. Can I find the greatest common factor of this mishmash stuff, two monomials like that? Well, once again, I have 40 and 48. So I'm going to take a look at those and see if I can find the greatest common factor of those guys. I'm going to do it this factor stairs method here. I know that 2 goes into each of these, so I'm going to get 20 and 24. Looks like 2 will go into these again. I'll get 10 and 12. And again, and then I get 5 and 4. And then I'm done, because there's no other number that divides evenly into 5 and 4. So my greatest common factor, the number parts, is going to be 2 times 2 times 2, which is 8. Now, a little tricky when I look at the A's and the B's here, and a good hint here is to look at what they have in common, but then take the smallest exponent. Smallest exponent. So they both have A's, but if I look at the A's, here's an A squared and here's an A to the third, the smaller of those exponents is what I have to use because it's the common factor. They don't, each of these doesn't have an A to the third, but each of them has at least A to the second. And then I do the same thing with the B's. They both have a B certainly, but the smallest exponent has to be B to the first. Alright, so anyway, we'll keep practicing on this stuff in class. Sorry for the discombobulation and all that kind of stuff. But that's the deal there. Once again, here's a little trivia for you. As we're talking about greatest common factor, I had a student last year in one of my classes who I called them GCF. So if you can figure out who that person was, they're actually still in school this year. If you can figure out who that person is and be the first person to tell me, I'll give you some extra points on your assignment card. All right, thanks for watching, everybody. We'll see you guys in class.